Awesome. Thanks for having me. Uh, Very cool. So, fun fact. I've been in the security industry for a while. I really didn't speak at a lot of conferences for many, many years. And the first conference I ever spoke at was here at LASCON several years ago. So it's awesome to be back here, and I love the audience. I love how technical everyone is. We're going to get pretty technical today. How many people, show of hands, could consider themselves technical? Awesome. This is exactly why I come to LASCON. How many people program once in a while to occasionally? Awesome. So we're going to get hands-on, and hopefully the demo gods are on our side, because I'm actually going to do some live coding today too. So we'll do some live coding, live compilation, and we'll kind of roll the dice on that. So a little bit of an intro. I'm co-founder and CTO of a company called Previty, which is focused on application security. I worked at NASA. That's where I started my career, which is a far cry from my degree, which happens to be in business and finance. So very weird how I ended up here. I'll share some of those anecdotes and what's going on with all that. MySpace, who remembers MySpace, the social network that time forgot? Yeah, some, again, diminishing population there. And then BBC Worldwide. Again, I speak now at a lot of these OWASP events. It's fun to be a part of this community. And I love photography, and maybe you'll see some photos in the slide deck, maybe not. So what we're going to talk about today is, I want to give you an introduction into language security. Sometimes you hear it called LANGSEC. I actually want to dive directly into some practical applications. We'll do a code walkthrough with a language that I call KSQL. And it's a minimalist SQL. It's a subset of traditional SQL language. And we'll talk about how you can get involved with LANGSEC, pointing you to some tools, some frameworks. And all the source code, all these demos that you're going to see, they're already available on GitHub. I know this is an audience that likes to break out laptops. Feel free to jump on to my GitHub. There'll be a link in a little bit where you can go in, download the source code, and you can also play around directly with all this stuff as well. So where are we today? Is kind of fascinating. I've been in AppSec back when it was called InfoSec in 2004. And what's interesting is that the methodologies have remained relatively consistent over that period of time. So when I think about security, I think about it in terms of vulnerability management on one side, and then I think about protection and sort of runtime as controls on the other. And I really want to focus on the protection side. And the methodologies that we typically see today, things like static signatures, dynamic signatures, and behavioral as well as statistical analysis. The first two are fascinating. The first one in particular, string replacements, simply looking for the presence of a phrase and then replacing it with another phrase. Dynamic signatures being regular expressions. How many people here have written a regular expression before? Yeah. So everyone here is mostly familiar with it. They can get pretty gnarly. I'll show you one in a second of a really nasty regex. And then you also have behavioral as well as statistical analyses. Now, the interesting thing about all of these is that they work to a particular extent, and they fall down when certain things happen or when certain conditions are in fact met. And I'll start with signatures. So there are a lot of systems today. I'm not going to throw any control or any vendor or anybody under the bus. It's not about that. It's simply talking about signatures in the aggregate. And the point is that there are a lot of systems that rely on regular expressions to try and solve things like cross-site scripting or SQL injection. And so for something like cross-site scripting, the presence of a JavaScript tag, or for something like SQL injection, if something says 1 equals 1, or introduces a trailing comment at the end. Here's an example of cross-site scripting regex. Pull this out of a open source technology. And what's crazy is I have written lots and lots of regexes in my life. I cannot tell you what this is going to do. I can tell you that it's trying to look and do something with script tags, right? You see, I think, 1, 2, 3, 4, almost a dozen script tags, or maybe 10 or so script tags in this thing. But I have no idea what this is going to do. And yet, a lot of production-laden systems, even open source ones, rely on signatures like this. And you have to maintain these things over time. The problem is, I don't have to have anything that looks like an alert or anything that looks like a document.write. I could do this. I generated this with an open source tool called JJ Encode. If you haven't heard of it, I highly recommend checking it out. It's just do a quick Google search, you go to it, you type in some JavaScript, and it generates this fuzzed input for you. And this isn't even that complex. If I wanted to, I could turn this into a palindrome. That's even nastier than this, so it just doesn't fit on the slide and isn't really legible. But the point that you're getting out of this is I don't have to construct JavaScript the way that regex is potentially going to look at capturing that information, which means I don't have to have letters, I don't have to have conventional strings like the word alert or the word document in there. I can work around that. And this is one of those examples where it's using things like shifting, it's using mathematical casting, which is casting from an integer to a letter and then from a letter back out to a number and moving those bytes along. Eventually, it's creating a lambda, and the lambda is being executed at the end. Really nasty, but this actually does in fact work. So I've played the signature game, going back to my time at MySpace. How many people remember the Sammy worm? Yeah, I had to clean up after that. And I want to tell you a story about that. So when I got to MySpace, I joined the company, and they were mostly developing their software in .NET at that time. They were coming out of a language called Cold Fusion. Who remembers Cold Fusion? Yeah. I came out of the government, right, at NASA. We had lots of Cold Fusion over there. And I know that there are a lot of shops around. No one really admits to it anymore. It's like one of the few things people remove from their resumes every few years. Cold Fusion kind of slides off. But MySpace was a shop that was transitioning from Cold Fusion to .NET. And the way that they were thinking about security was all reactive. Everything was around creating a regular expression or a string replacement. So every time someone found a workaround, there would be another regex. That nasty cross-site scripting regex that you saw, we had more than 5,000 of those. And 5,000 that have to execute on every variable for every HTTP request. So for those that don't remember, MySpace had what was called a profile. And the profile had about 20 different fields. So if you do the math, and now you've got 5,000 regular expressions that have to operate on every single one of those fields, how many invocations do you have running for every HTTP post request every time you submit your profile? That's a lot. That's about 100,000, right? You're 5,000, 20 fields. You have 100,000 regular expression matches and replacements that are happening every time someone clicked that submit button. And that was nasty. It was nasty because it was really difficult to maintain, really onerous to manage. And the problem that we had was every time we introduced something, we would break good behavior. And we'd have the head of the company, MySpace Tom, would walk over to your desk and say, well, you just broke 1,000 profiles, or you just broke 10,000 profiles with this new signature that you just added. And it was really difficult to play that game. Now, database regexes. Look, we all know about prepared statements. This is the audience that knows about it, more so than anyone else. And I'm sure we go around our own organizations kind of beating people over the head that don't use things like prepared statements, or query planners or query builders, like traditional or modern ORMs. The problem is there's still a growing majority of people, and I say growing majority because I've seen this now, having gone from big enterprise to big enterprise, of people who still think that you can use regular expressions to look at database queries. And I don't understand that, especially when it comes to things like static comparisons, dynamic comparisons, and my favorite, tautologies. So these are all examples of tautologies. And before I go into each one, tautology is a statement of truth. It's a way that you can create an equality or a statement of truth. And one way you do that is via an equality. So in the first query where you see 1 equals 1, that's something that we probably have all seen before. But the next two are also valid tautologies. So 2 equals 1 plus 1, or 3 equals 1 times 1 in parens plus 2. All valid queries. You could actually send this right now if you wanted to in your REPL to your table, and all of these three will execute and do exactly what you think they would, which is short circuit the evaluation, because the second condition of the OR clause is going to be true in each one of these instances. And I just was really, really primitive here, and I only have very simple arithmetic, but you can get more complex. I've seen trig before go in. Sine of 1.57 equals cosine of 0. It's valid. And believe it or not, the underlying databases will treat that as a statement of truth, and it's going to match that equality. So how do regular expressions compete against these? And we're moving away from 1 equals 1 now. How many people here have played with SQL map before? A few. SQL map is a fun tool. Load in your database schema, run this thing, and it's going to generate lots of queries. And it does a pretty good job at generating some pretty nasty queries. But could you imagine if you take it up a notch from just 1 = 1 to include mathematics or include trig? What else is going to fall down? You'd be kind of surprised. And there's an area around using, and what I'll talk about, LANGSEC for generating things on the offensive side. So we need something better, right? When you look at what's going on with cross-site scripting, when you look at SQL injection, we need to look beyond string matching, string replacements, regular expression matching, and regex replacements to actually understand how things might execute. And when we talk about web applications, we're talking about things like the web browser. We're talking about things like a database engine, the underlying operating system of these applications. And we need to be able to understand how content, or something like a database query, something like an HTTP snippet, is going to execute in the underlying database, or when it goes back to a web browser. And we also need this to be pretty fast. And this is where LANGSEC comes into play. So I look at it as another methodology. So you recall that we're talking about strings, regexes, this analysis with behavioral or statistical analyses. But there's this other methodology called LANGSEC. I can't take credit for creating this term, LANGSEC. It was actually coined by Meredith Patterson at Black Hat in 2005. And she presented this idea of treating input as a formal language. The idea of, I'm going to be collecting information like content through a web browser, like think about MySpace, HTML potentially from users, or I'm looking at SQL that's going to an underlying database engine. What if I could look at the content the same way it's going to execute? What if I could look at a database query the same way that the query planner is going to execute it, or the same way that a browser is going to process an HTTP variable? And you can do that if you go down the path of LANGSEC, which forces you into building a grammar and rejecting input or modifying input based on what the grammar sees via tokenizing and parsing. So LANGSEC has great applications for I/O-laden applications, which is perfect for web apps. And you can embed it into an app runtime, which is the focus of this talk. So we'll talk about the theory of LANGSEC, and then we'll talk about how you put it into the runtime. Now, when we think about web app I/O, we think about things like query string parameters, request bodies, database queries, and I've mapped it to the underlying, or to the OWASP category that's loosely related to it. So when we think about query string parameters, request bodies, we think about cross-site scripting, whereas when we think about operating system commands, we're thinking about command injection. And the way that LANGSEC works is 4 steps overall. One is around lexing, and lexing is really about taking a string of content and building it up into tokens. So when I see the word hello, there's going to be HELLO. Those are going to be tokens. And you can be reductive, and so you can then take those characters and glue them together, and that makes up a word. Then you have a parser. A parser's job is to take all those tokens and produce a parse tree. And once you have a parse tree, you have an understanding of the structure of what it is that you're looking at. And when we go into a live demo, we're going to actually code live queries, and I'll generate parse trees for you live. So I'll put in real queries. You'll see a parse tree that gets generated just to visualize how it all works together. Now, the last 2 are what makes this interesting, because the first 2 you could think of, for those that have a CS background, you've probably seen those first 2 when it comes to compilers and compiler-related technology. The bottom 2 are what kind of differentiate LANGSEC from your traditional compiler. Because once you've got a parse tree, you can evaluate it. And in the case of security, you can then look and do things like evaluation. Like if I'm looking at conditions, I can unfold mathematics. I can unfold 1 + 1 = 2. And if you see that and you have the ability to do that, you can go into the 4th step, which is transforming it, which is you can modify the parse tree. I can change it. So if I see a statement of equality, or if I see a tautology, maybe I want to remove it. Maybe I can rewrite the query dynamically. And LANGSEC gives you all those abilities to evaluate, as well as to also modify. So before I dive into any demo, I want to talk about the various tools that are already out there. There are lexers and parsers that have existed for years. And these things do a great job. And I'll call out a couple of them, and I'll actually speak to a few of them. one that you see in both places, lexers and parsers, is this thing called Antler. And I'll actually be using Antler today. But Antler is a great tool. It allows you to build a grammar, and it can generate a parser for you as well as a lexer. So you don't even have to hand roll a lexer. You don't have to hand roll a parser. It'll just gen all of that code for you. Now, if you've used things like, let's say, BigQuery with Google, or if you've used Google Compute Engine and you use any of their NoSQL databases, you've gone ahead and used Java CC. Every time you write a query and you use GCE, what Google does as part of their GCE platform, they actually do something like LANGSEC, but they use Java CC to actually lex the content, and then they've written their own parser on top of that, as well as a lot of other cloud computing platforms that let you write your own databases. A lot of them ultimately have the ability to look at the query and let you do some interesting things with it. Let's say whether it's optimization for planning, or if it's looking for all sorts of behavior like run-on queries or poorly developed or poorly written queries before it goes off to an underlying database. And if you've used scripting languages like Ruby, Python, or PHP, you've played with things like Yak before. You've played with things like Lemon as well. You just don't know it. Every time you write something in Python, every time you write something in PHP, what's happening under the hood? There's Lex and there's Yak. Someone is actually going in, or something automatic actually is going in and translating the PHP that you're writing into machine code, and it's using Lex and Yak to do that. Now, you could always roll your own. But for this demo, we're not going to roll our own. We're just going to go directly into using Antler. So I mentioned this language called KSQL. KSQL is just something I made up. It's a toy language, and I'll actually walk through a few elements of it before we go into it. Why I picked Antler was it was easy. You'll see that there's a pre-visualization tool that Antler ships with for looking at a grammar. I'm also going to use Java as well. So I'm going to use something to develop a grammar. I'm going to use the output of Antler, which is going to be generated Java, inside of an application. So you can see what it's like to go from grammar to actual implementation of that grammar to determine whether or not something is safe or something is unsafe. We'll use Java 1.8. That's what's on my laptop. It's what Apple was kind enough to provide, as well as JUnit for testing. So I've talked a little bit about KSQL, and down here at the bottom, it may be a little small to read, but if you have a laptop, you're more than welcome to check it out at github.com/Anand Kunal, my name reversed, last name then first name, and /KSQL. And if you check it out, this whole project that you're going to see here, including the Antler grammar, the Java code base, is all available. But I wanted to build a SQL that was really tiny, because it would allow us to actually look at the whole grammar on one screen. We don't need to scroll as much to look at the grammar. I think the whole grammar itself fits in under about 30 lines of code. And then the rest will be all kind of magic from there. But the point of KSQL is I still wanted it to allow some kind of execution. So we'll be able to do selects, and we'll be able to do things with numeric conditions. So if we take a look at some of these example queries that are valid for something like KSQL. Select star from users. This is a wildcard, the common one. Being able to select multiple columns, so username, password from users. And then the third one, select username from users where ID equals 1. And I've got it where it's a identifier equaling some numeric, but you could also have numerics also equaling another numeric. So I also mentioned why we picked Antler. I didn't go into a bunch of other reasons why I chose this. One in particular, and I called it out here, is that Antler can output into multiple targets, including C#, Go, Python. There are Ruby bindings now. There are also JavaScript bindings. So everything that you see here that I'm doing with Java, you could do in any one of your other targets. So if you wanted to incorporate any of these components, let's say in your Python code base, you could easily do that just by instructing the Antler tool to generate Python instead of Java code. And you'll see the command line for how to do that. OK, so let's go directly now into the demo. Can most folks see that? All right? All right. Sweet. See thumbs up over there. So this is an Antler grammar. And no joke, 32 lines of code with comments and white space. But the way you define an Antler grammar is you start with this top line that says grammar KSQL. I'll just bump that up a little bit more. and you define what are called expressions. So expressions allow you to build more complex rules. So this is the root expression, EXPR. And I could call it anything I wanted to. I just picked EXPR. It was something that is more or less convention that I've seen in ANTLR grammars. And right now we just have a select expression. And the way that we've defined select is, and I'll just bring this down a little bit, select, which is going to be a keyword, column list, you'll notice that's lowercase, that's going to be another rule or another expression. From table name, we'll get into that one, where expression, and that's optional, and then the semicolon. Now, if this is your first time looking at a grammar file like ANTLR, you'll notice that it's awfully familiar and similar to things like regular expressions. If you've written a regex before, this might make a little bit of sense. And again, I'll kind of zoom out a little bit more so you can see more of this on the same page. But when you unpack something like select, that is a keyword that I've mapped to down here. And you'll also notice that I've got two variants of it, uppercase and lowercase. Because with the grammar, you have to be explicit about what input you're going to process. So you'll notice that this grammar doesn't support leet casing. So if someone wants to do lowercase s, uppercase e, lowercase l, this won't see it. Because the grammar that I'm specifically trying to match on is all uppercase select or all lowercase select. And all of these rules that you see here cascade beneath the select expression. So column list, well, I'm doing a check to see if there's a wildcard or column name, comma, column name. And I'm allowing other columns to exist, provided that there is a comma and another value over there. So again, if you've seen regular expressions or manipulated those before, this might look relatively familiar. Now, if I wanted to go back in and visualize this grammar, this is where ANTLR becomes pretty cool. So I'm just going to go to the command line here. I'm going to kick off this command. No, it's not as legible in the back. But all I'm doing is I'm calling ANTLR on the grammar file, and then I'm calling javac on the generated ANTLR code to generate my Java files. And I'm using this thing called grun. And I pass in my grammar file name, which is KSQL. And I'm telling it to load it up in a GUI, which means now I can start to see and play with what my grammar file is actually doing. So if I try this one, select star from users, takes a second, and there you go. We have a parse tree. And I'll zoom in a little bit. Again, it might be a little hard to see in the back, but remember that root expression that we talked about? That's at the top. And we matched to a select expression. We saw the keyword select. Column list worked all the way down to a wildcard from being another keyword. Table name is users. So let's try a little bit more so you can see how dynamic these parse trees can get with the grammar that we've developed. So if we go in and we type in select user PW from users, and this time I'll actually leave the semicolon off, because again, we specified that as something that's optional, you'll see that we're able to go in here and generate a much richer parse tree where we're not looking for wildcards anymore or finding wildcards, we're actually finding individual columns now. And if we go back in and start to look at literals and doing conditionals, we'll try this. Select star from users where ID equals 1. Again, a little bit richer of a tree. But you'll see that we've shifted things down and identified that there is a dynamic comparison happening here where we're matching on some column. So this comes out of the box. I didn't have to code anything. I just made a grammar file, and I'm running ANTLR on the grammar file and testing it with real input. So this allows me to iterate really quickly. I can go in and verify that this grammar file is working as intended. Now let's try something that we know doesn't exist. Delete. Delete from users. So you saw that error, missing select at delete. So it has no idea at this point what's going on. And it's trying to assume that delete is in fact a column name. And the users is correctly matching to table name because it's coming after the from clause. So let's add support for delete. It's actually not going to be that hard. If we're going to go in here, So we've got select expression. Let's do delete expression. And let's create that. Delete from table name. And I'll also go in and steal the semicolon stuff at the bottom. We'll close that off. Now I don't have the delete keyword, so I'm going to need to add that. Delete, delete, and I'm going to be crude and just have the uppercase and lowercase variants. And now let's just go in and rerun the grammar file again. So delete from users. Close that. No error expression this time. And there you go. We just added very trivial support in KSQL for delete, just by adding in a couple of lines in our grammar file. OK, so this is just part one of what I wanted to show in the demo. I'll head back to the slides now. To recap, we started at the root expression, expr, and we defined all our sub-expressions. The line that you see below, that Antler KSQL G4, will go and take the grammar file and build out into my target. And in this case, my target is going to be Java. And I'm then running Java-C on the KSQL output to generate Java source code for me. I didn't write any of that. That just comes out of the box. And I can also run, and you saw that chain command at the end, grun, which ships with Antler. And I can run that on the output with the GUI to go and iterate to see whether or not I'm building a grammar that is good. And you can go and start to automate with this tool to see whether or not you're supporting the language that you want to support correctly. It allows for rapid iteration, which is really, really nice from a security perspective, because it means that you can collect a bunch of input and then iterate, iterate, iterate to make sure that you've got the correct grammar. And if you don't, well, you'll know very quickly. And if you chain this together with automation tools, you can write reports on the other side that show you where the gaps are in terms of building support for grammar. So now let's jump into how we're going to use this in Java. You can take the Antler target, and what we're going to do is we're going to take the pre-built parser that Antler creates. It's called KSQL parser, and we're going to put that into our code base, and then we're going to call it. And we're going to write some security functionality on top of that to reject queries and analyze whether or not a query contains good stuff or bad stuff, depending on the rules that we want to create. So I'm going to head back over in here. And the way I want to start is by looking at the unit tests. So I'm a firm and strong believer in testing, especially when it comes to building security tools. It's fascinating because there's a lot of folks that take DevSecOps on one side and then DevSec, because I think that came first, or SecDev came first before this DevSecOps stuff. And for a long time, we were iterating really quickly as security teams and as AppSec teams, but development teams weren't including or providing good habits back to security teams. I've been there, where development teams were practicing things like testing. And as a security team, we weren't properly doing that. And we weren't properly unit testing. So we were building all sorts of stuff in our kingdoms and our fiefdoms and going around with sticks. I see head nodding. We were going around with sticks across engineering organizations and telling people, oh, you got to do this. You can't do this. You have to do it this way. But we ourselves weren't practicing good hygiene. We weren't testing. So when you're building something like a LANGSEC-based approach, you can test. And you can test really, really efficiently. So everything that you saw before, I'm going to show you how you can test that now. So I wrote a function that wraps all this stuff up. And I'm going to jump into the source code here. So jump into this. It's called intelligence. So it's a class. And all the intelligence class does is it wraps the Antler generated code. So Antler is going to go in and generate a lexer and a parser for you. OK, I'm just going to use it. And these are the 3 lines for how to use it. The first line is you create a lexer on the input stream, which is just going to pass in the string that you want to look at. And then you pass the lexer into the parser. And then when that's done, you start at the highest level. And in our case, it's the expr. We want to start at the root expression. And then we want to work down from there. And this is the idiom that Antler employs for at least one of the ways that Antler does it, where you can go and react to things as they're being parsed, or you can go in and manually invoke and kind of go through the parse tree itself directly. So what I'm going to do right now is, in this particular approach, I'm not going to use a listener model. I'm going to manually go through the parse tree. So I start at the top, and I start at the context root, and I see if it's a select. And this is the way you check to see if you're in an expression. You have to do a null assertion. It's just kind of their API. And most APIs, most modern APIs, you would check to see if you're in that particular state. The way it works with Antler is you have to do a null check. And so you'll see that these null checks happen all throughout the code. So if I'm in a select expression, I have to go down and cascade here. Okay, I'll collect things like, and set things that the statement type is a select. I'll select the table name. This is how you get at that information. So that generated tree that you saw, you call functions like table name, which is going to be the rule, get text. And get text is going to return back a string. And you can do whatever you want to do with that. So there's this class called intelligence and a method called build, which is going to go through these parse trees and build up this intelligence object. Well, if we wanted to test our grammar was working, we would do checks on intelligence. So if we wanted to, we could go back in, and I'm going to go to the root here. I'm going to use Maven. So that's how, that's the way that this project was put together, using Maven, not Gradle. And so Maven allows us to create life cycles. And one of the life cycles, or one of the life cycle stages I have, is a thing called test. So what's included in the test is to run all of those unit tests. So I'm going to tell Maven to clean whatever's in the directory, and I'm going to tell it to run test. And so it's going to run, in this case, this intelligence test. So we're going to go through, and we ran the tests. We ran 13 of them. We had 0 failures. And I'll tell you what we were asserting on. Remember those cases that you saw in the terminal, where we were doing things like select star from users? We're going and passing that query to the intelligence object, and then we're just making assertions on the intelligence object to say, well, was it actually a select? Can we prove that the table name is in fact users? So if we wanted to now go and complete support for what we just added, which was delete, we could do that here too. So let's go in and let's call it test delete. And if we have delete from users, we're going to build this up. We're going to just do something primitive to see whether or not that it is in fact a delete statement. We have no columns. And we're going to just check that the table name is in fact users. So we'll go back here. We had 13 tests before. We're going to go through and rerun Maven one more time. So Maven is going through. We just ran 14 tests with 0 failures. So again, didn't have to write anything special. I just had to work around the output that Antler was generating. And in this case, I was able to use that inside of my application. And so where it gets fun now is if I wanted to start to use that intelligence object to build rules. So how signatures are to, for instance, individual strings or characters, you could then use the intelligence object plus some other rules. Maybe you want to allow certain kinds of input in your application. Maybe you don't want to allow input that contains deletes. Maybe you want to restrict queries that have tautologies like 1 = 1 in your environment. Well, you could wrap all of that up if you wanted to. So one way that you could do it is, and I've got down here in the intelligence structure, a method. Let's go into security test called secure. And if I go back in here, and I have this in here, I can pass in things like bad statements, bad tables, bad columns, if you want to block static tautologies. So what that means is you can then allow people to build rules or policies on top of this language-driven approach. So without having to build regular expressions that have to hunt and to figure out if you're actually blocking something because the table name is users or if something is 1 = 1, you could just say a Boolean or provide a Boolean that says, I want to block on static tautologies. And the way you would do it is, if someone passes it in, and if the static value is equal to the other static value, you know that's true. And so in this case, it's evaluation. I'm actually going to evaluate those two values together. And the neat thing about that is it doesn't have to stop here. You can actually make it much, much more advanced. So you can go in and let's say you wanted to test a bad statement. You could throw in a set a series of bad statements. And in this case, delete. Let's say you don't ever want to allow deletes. Okay, well, you can build and then make an assertion on the secure flag that this is in fact insecure. And this is just a couple of ways how you can use this in your own application. So what you saw was taking a grammar file, generating Java output, writing a few Java classes on top of it in your own application, and then figuring out what your own use case is and then tailoring it to your specific case. In my case, I just wanted to show how you could use a policy-driven approach on top of building out a parser or using a parser and a lexer to determine whether or not something is good or bad. So I'll shift back over to the presentation here. So tautologies are interesting. We talked about the statements of truth. So 1 equals 1 is trivial. In the example that we saw, we can catch things like static or integer-based tautologies. But the thing that's kind of interesting is that you can go a lot more and be a lot more advanced. In the example that I have, I can only do things like numeric evaluation. So something like 1 equals 1. I can see it. I can evaluate that, and I can even block on that if I wanted to. But it doesn't support things like chained extensions. What if I wanted to have combinatorial madness of ands and ors and group all of those into various parens? Well, at that point, you need to build a state machine, right? You need to be able to unfold all those different states. There's also mathematical operations. So I just have equality. But again, what about addition? Well, remember that check I'm doing right now for blocking on static? You could actually do the same thing with numerics, where you could take all that information and see whether or not that both of those values on one side are in fact equal to the other side. You would have to actually do the addition though. So that involves bringing a sense of higher level or higher order evaluation inside of your application. And don't do eval. Just do not do eval if you're going to do this, because that's just going to open up a can of worms. Ultimately, you're going to allow for execution inside of your application. Instead, you have to constrain it. And if you know that you want to look for those things, you have to not only build support in the grammar, but you have to go in and build all that support directly in the evaluator or in the transformer itself. Now, how do you do this at runtime? Because this is also where it gets a little bit more interesting. So how many people here have familiarity with Java? Show of hands. Fair amount. For those that don't, Java is interesting. When you fire up Java in your environment, you have the ability to load classes. In fact, class loader is the very first thing when you start your Java application that fires. And what the class loader's job is to do is load in all the dependencies, all the classes to make your application run. Sometimes it could do it just in time. So if I haven't executed a certain part of my code, it's going to bring in those classes. You could use something like Java ASM. And so ASM allows you to go in and hook classes as they're being loaded at runtime using an agent. And you can then go in and inject this kind of evaluation directly into the methods. So everything that you just saw, you can go in and add every time SQL.statement.execute is in fact invoked, which means you can trap every single query before it gets executed. So you can do the LANGSEC computation at runtime. And the neat thing about that is you don't have to deal with things like network proxies, unmarshalling packets, trying to deserialize all that information when you may not necessarily have the context, whereas inside the application, you do. And the neat thing, and I know you can't necessarily see it in the back, is that if you can compress all this together, you can start to glue everything from within the application, including the database-specific information, plus all the HTTP metadata. And if you're operating at runtime, you can even bring out things like the file name as well as the line number. So in one place, you could be able to say that here, in fact, I have a tautology or a tautology executed exactly on this line in this file, and here's the state of the application when that thing actually happened. And that's what's really cool about LANGSEC plus the runtime component, is you can glue all that metadata all in one place. I know I'm getting relatively close to the end. I'd be remiss if I didn't talk about performance testing, because performance testing is really important. Remember, we wanted all of this to be really fast. Well, what I ended up doing was using something called JMH in JavaLand. And JMH is a really interesting tool. It allows you to build annotations on top of methods, and it can do performance benchmarking. So if I wanted to do things like throughput analysis, I could. So I did a LANGSEC implementation of being able to parse HTML, and I compared that with regular expressions for how to evict cross-site scripting using those signatures that you saw. And the test payloads varied from 70 bytes to a megabyte. The way I generated the megabyte of text was I took Project Gutenberg ebook, Alice's Adventures in Wonderland, and I actually laced it with cross-site scripting. So it's actually available also on GitHub. So it's the ebook, but it's got all sorts of junk HTML, and it's basically a megabyte of real bad stuff. And the reason why I picked that was I wanted to really do a benchmark to see just how much faster this was compared to regular expressions. The regexes I'm using were taken from the OWASP wiki, as well as from IE 9 through 11. You can Google it. I won't give you the URL, but someone was kind enough to take the Microsoft IE security DLL and just do, I believe it was just running strings on the DLL file and output all the regular expressions in there. So it's how they prevent against DOM XSS. So that regex that you saw before, plus many, many more, are all packed inside that DLL for looking at DOM XSS. And so generally what I saw, I know this table is pretty difficult to see, compared to 50, 100, and 500 regexes, LANGSEC is incredibly fast. It's also important to mention that in this case, LANGSEC is single-threaded. It's not even multi-threaded, whereas running the regular expressions was supposedly efficient because they were all glued together into one monster regular expression. So it's not like we were creating the overhead of manipulating and augmenting multiple strings at a time. They're relatively compacted. It's ultimately a state machine that still has to execute on the other side, versus LANGSEC is one loop through the entire input and then evaluation where you want to do that. So I actually had to shift the y-axis into logarithms or into generations for all of it to show up into one graph. But the LANGSEC implementation was far and away faster than all of the other regex implementations, at least when it came to HTML processing. I can't even imagine just how much faster it's going to be for database processing, especially given that with databases, the language and the corpus of those languages are much, much greater. So when it comes to DevOps, I think the thing that's kind of interesting is I've seen some interesting approaches of people taking LANGSEC, whether it's connected within an application runtime or not, people adding it to their applications. So people want to bring LANGSEC to their applications. Maybe it's through runtime, maybe it's through the network. There are also really interesting implementations I've seen of people taking LANGSEC and putting it into network-based appliances as well. Now, if you put it into an app, the app means that it's got to get in there somehow. Either developers are putting it in there manually or they're going through some build tool. The neat thing with agents is that you can move really quickly, and you can also insert all of this via an agent via tools like Puppet, Chef, or Ansible in your environment. Some other fun applications of LANGSEC that I've seen and I would love to see more of. One is data masking at runtime. This is kind of an interesting one, because if you can look at all the information going on inside of an application, maybe before you log something, you may want to redact information. Maybe you're processing a query that contains credit card information, and you want to log that query. You want to log it without that credit card info. Well, you could use LANGSEC to do that kind of redaction for you. If you know that the literal you're looking at conforms to a credit card input or something that looks like a credit card, you can redact it. You can also do things like generating histograms. I think this one's really, really neat. Not necessarily something that lives in the application, but something that lives outside of the app, where you've now processed all sorts of database queries. You want to go through that process or that log to see what people actually accessed. So imagine being able to generate a graph that says, here's the number of selects, inserts, updates, here's how many times a particular column was accessed, or here's an anomalous function that we just haven't seen before. I think it's really interesting when you couple those things together. So I'm at my last minute. I want to touch on where I think the space is going. LANGSEC has been around for a while. Meredith coined this term in 2005, and now there have been some really interesting implementations of it. There is a IEEE conference that happens every year. I highly recommend for those that are interested or curious about LANGSEC to check it out. Maybe send someone from your team or you yourselves go. It's transitioning from being a purely academic conference into a conference where it's getting more practical now. And I think there's a lot of potential for both the offense as well as the defense time. I also think that there are some interesting applications as well. And finally, I think there's lots of ways that people can get involved and you can get involved too. I personally would love to see the Netflix prize of LANGSEC come up, where we can contribute a bunch of grammars together. We can create more test beds around current SQL implementations or browser implementations, so we can understand exactly whether or not the input that we're processing is in fact correct. You saw one of the challenges is if you don't have the correct grammar, you may not be able to process the input at all, which means that in order to be successful, you have to really understand the target environment that you're going to be supporting. In this case, it's KSQL, but if I wanted to support another database engine, I would need to figure all that out. And that's where we think that the LANGSEC community needs to drive to, is a Netflix prize for generating more data sets, which will help with testing, as well as coming up with more common algorithms, which can really help the community, and I think overall, building higher performance-based solutions. And finally, just evangelization. So I'm totally at the end of time, thanks to the timer here. So I'm sure there's going to be some questions. I'll probably be out there, and if anyone has any questions, feel free to come by. Would love to talk. And if you guys are thinking about LANGSEC or have implemented LANGSEC controls in your environment, let me know. Would love to learn about it. Thank you.